Before we begin with that expanded material, I wanted to secure closure on the model from this morning, because when you left for lunch, there were things still not right with it. And even after I went to lunch and feasted upon the Subway sandwich, I found my stomach was full, but my heart was not yet full, because the model wasn't yet running properly. Does anyone remember the dysfunction that we observed, the pathology that befell us? How was it manifested?
The network wasn't fitting with the newborns.
Indeed. Newborns were being added to the model, but they weren't knit into the network. By contrast, immigrants were being knit into the network with readiness, but newborns were being added as solitudes. And I definitely and desperately wanted to fix that strategy, and I tracked it down. Sure as night follows the day. I found the problem, and the problem, ladies and gentlemen, the enemy, as Pogo said, is me. So I want to show you the problem, because it's a problem that may befall you. Okay. And it has to do with the decision that I made, admittedly somewhat hastily, in the opening sessions of this boot camp. I made a strategic choice as to how I would present some of the programming to you, and I chose to simplify out a component that I thought would be a distraction, nay, that I thought might confuse you unnecessarily. And by simplifying it out, I missed a key opportunity to nip this problem in the bud, to spot it. I left open the door for this vulnerability to enter and to befall our model. So I stand before you to offer my apologies for that, but I'd like to show you what I found in concrete terms. May I? Okay, so this won't take long, and it'll be mostly painless. Okay, so what had happened is that we had an immigration. Oh, and I'm going to have to make sure that let me restore this to its original condition. I was experimenting with things that shed light on the issue. Okay, so we had an immigration event, and the immigration event determined if the immigrant was infected by flipping a weighted coin. It determined if the immigrant is male or female, and then it added that immigrant to the population. And then finally, does anyone remember the final step of it? What did it do after this? It knit them into the network. It applied the network. Now, this is a beauty curve. Notice this apply network column here. And in fact, you notice this add population. I just call it add population as if add population is some service being offered by the general framework. Apply network, I'm just calling it as if apply network, someone magically applies the network to this. But the fact is that this is a fiction. It's a convenient fiction. It's a bit of syntactic sugar that simplifies the presentation. But there's actually something going on there that I didn't want to talk about too early. I didn't want to scare you. What this really means, in concrete terms, is nothing less than this, literally. This dot add population, this dot apply network. I'm actually requesting that I add to my population these things. I apply I, meaning the main class, apply the network. This dot apply network means, hey, myself apply the network, myself add the population. And in AnyLogic, and by extension, actually Java, in Java and by extension AnyLogic, which just simply builds on top of it, you can omit those because it's considered so obvious. It's just, I'm asking myself to do it. So by default, of course you're asking yourself to do it most of the time. It's only when you ask others to do it, you're requesting something of others, like of the sex class, that you actually have to put in this thing with the dot there. Now, however, if I had been careful about putting those in, In about half my boot camps, I put these in religiously because I figure leaving them out will cause more confusion than it will save. And the other half, I leave them out, and I think the other way. So this time I left them out. And I said apply network. And then, going to that other code, what happened is, we had code, and this code notably is in Maine. Do you see that? This immigration event is in Maine. Why is it in Maine? It's in Maine because these people are not yet in the population, and it's kind of a population phenomenon. People come into the population, and so this fires off periodically with a certain rate, and each time it fires, it brings someone into the population. So it comes in at an immigration rate, certain rate per year, and each time it fires, it does this thing and knits them into network. Fair enough. But where was birth handled? Does anyone remember? So this is one aspect of an open population of people coming into the model. Where was birth handled in this model? Does anyone remember? Birth occurred to a mother in this model, and therefore it was handled where? Was it handled in Maine? No, it was handled in person. So let's go down to person. Here we go to person. Ladies and gentlemen, okay, let me mute this and show you what it used to be, so that you don't see the answer too quickly here. Okay, this is what it used to be, like this. A baby was born, and a baby was born. This is what it used to say. Boom. Okay. This is where it was handled. There we go. I didn't want you to see the answer before being able to narrate it. So this is what we had for birth. Birth occurred after the completion of the pregnancy status after 9 months of coming in here. A person delivered. Remember, this is in continuous time. It sort of keeps track of those 9 months. And when that birth occurred, some things had to happen. And what happened is we said, and Kurt, this is the I think you know where this is going. Yeah. Main.add population. We asked Maine. Notice we said main.add population. Why are we saying main.add population? Because who maintains the population? Maine does. So we have to ask it to do this. And then I said apply network. And that, ladies and gentlemen, was the fatal error. If I had the convention of never writing something like that without being explicit, I would have written this as this.apply network, and I would have, oh my gosh, I can't do that. Who do I have to say apply the network? Who maintains the network? Myself? Each person has their own network? No. Main applies the network, folks. This should have been main apply network, not apply network here. So literally the same code copied from that context, apply network in main, worked, but when copied here, it wouldn't work. Because I was asking implicitly in main, it was asking main to apply the network. Here it was asking person to apply the network. And the person says, well, I don't have the network of people across the population to apply. I'm done. So here, we need to ask main to apply the network. Hey, main, go figure out the network for everyone so that I'm woven into it. So this new baby is woven into it. So main.apply network. That was the secret. That was the answer. And if only I had been explicit about it, I would have caught it, because I would have noticed myself writing this and said, whoa, we don't need that. This is what we need. Kurt.
So this is a good learning opportunity here, though, because
Indeed.
Because the idea of apply network, like there's a function in main called apply network, right? And so that function takes any of the networks that are in main and sort of like resets them, right? Like it sort of calculates for each person that's in that network, it calculates their distance and draws the line if it needs to be, like all that stuff. Now, if you're calling apply network in the person, that means there's also a function in the person called apply network. So what would that do? So if you scroll up, maybe on your screens, you'll see a thing called connections. And you'll see that thing called connections in both in person as well as in main. So what that tells you is that you can have agents within a person. Right? You can have agents within agents. So you can have a network of people at main. Like you have a network of homes.
Or a network of farms, and each farm could have in it animals.
Yeah. So you can nest agents within the site. So basically main and person are the same thing. They're just named differently and one's inside the other. It's those Russian dolls.
That's right.
Right? So applied network exists as a function in every single person. It's just that it accesses a different network.
In this case, person doesn't have a network to maintain of people, of things under it. If this were a farm, it might have a whole bunch of animals and people within it whose network it will be maintaining.
Right.
And so it would make perfect sense to call it a supply network. But in this case, there ain't no network inside a person that is maintaining for others, so we really need to ask main to apply network. AnyLogic is, computers are stupid by and large. They do some things, very simple things they do in a very fast way, a very regular way. They can do that really well. But when it comes to being very clever, often they really fall short. And this is a case where it couldn't clue us into this error. It just happily said, oh, okay, I'll apply my non-existent network, and I'm done. Done for the day. And that's why it didn't work. But there was a question.
Yeah, I was just wondering if you wanted to connect the baby to the mother, then would you have to specify, like, you're connected to this specific?
That's exactly where we're going right now, to show you, to deepen this learning opportunity. Remember mistakes in the model, cases where a model doesn't match empirical data, cases where a bug has been found, they're learning opportunities. Mistakes in life are learning opportunities. If we turn them around and take advantage of them, they can be real assets by helping us learn. So that's exactly where I'm going to go. Any other question? Did someone else have their hand up, though, before I answer this question?
I was about to ask the same question.
Okay, yeah. So let's go do that. Let's go add this in. Let's go show how these features work, and particularly this notion of this that I kind of waved my hands at here. This dot add population, this dot apply network. How does that apply? Let's go check it out, because at some point you got to talk about it. I didn't want to talk about it yesterday, and I regretted it. Okay, so ladies and gentlemen, here we go. End population. I'm going to connect the mom. I'm going to have the mom be located close to the baby so that they're connected. In fact, I'll even connect them explicitly. I'll put them near each other and I'll connect them. Is that okay? Okay, watch this. So show dynamic networks manually done as well. So this add population, this actually returns a person. The person who's added creates and adds an embedded object in this, and it returns the newly created embedded object. That's, in this case, the person we're adding to the population here. The person is being delivered is the what? Is the baby. It's the baby. This is the baby that's being added here, and I have a reference to the baby. Okay? Now, who is the mother? Who is the mother here? The mother is the person who's giving birth. It's the person whose code is running here, who's delivering this. So, the mother is simply me. It's this, the one that's currently running. That's what this denotes, sort of the one who's currently running. The one who's undergoing this transition is the mother. And we call that this. It's the one who's undergoing this transition. It's the one who's undergoing this transition at other times. It's this. It's sort of the current thing that's executing. It's the one who's going across this transition, triggers this code when this transition is crossed. So mother equals this. That's a reference to the mother. And the baby is there. So I'm going to say a baby named, got that. No, it's not going to name them Nicole or Kathleen or Joe or what have you. It's just going to be a computer-generated name, but it will have some utility. So a baby named whatever was born to mother. These pluses just mean concatenate whatever's here, the name of the mother with this string, put them together, append them, and append it to this name of the baby, this string. So it's going to print out. So we'll get to connecting them in just a moment. But meanwhile, let's run this thing. Okay? Here we go. So I'm going to build this, make sure it's a happy camper. It is. And now I'm going to add in, I'm going to have this with no immigration, just so we could see the births occurring more definitively. Days pass, seasons change, and now we're getting to babies being born. Let's go see what's printing in the console here. Oh, look at that. Here are these babies being born. Okay, there it is. Baby 345 was born to mother 195 in the population. Mother 195 gave birth to that one. Mother 94 gave birth to baby 344. Number 344. What are these numbers? What do those mean? Well, let's run this thing. Here we go, and we'll speed it up again. Okay, and here we go. Now we're getting into post-gestational times. Babies are being born. There we go. Okay, let's go look at the console again. Here it is. Baby 250 was born. So, in other words, person 250 in the population, that's what root.population means. Root refers to main. Was born to person number 38. Who are those persons? Well, it's exactly this. Person number 38 is this one. Let's go view that mother. Here she is. She gave birth. This is the one. Number 38 gave birth to number 250 here. Who is number 250? Let's go see them. And there, ladies and gentlemen, is the baby who remains susceptible. The mother here, she's actually, oh, okay, since oh, you know what, Kurt? I think we removed that. We removed that as the process of debugging. Okay. She may have died since she delivered, but I did not re-enable that delete self to delete her when she died. Okay, here we go. Let's run this again with the deaths properly accounted for. Here we go. Hey, come on. Oh man, I don't want to be that far in the future. Okay, sorry. We're dealing with far future there. Okay, let's try this again. Okay, speed it up. Okay, we're gonna wait until the gestational period is finished. Come on. Okay. Okay. Yes. Now babies are being born. Okay. Good. Okay. Now let's go see those children. Okay. 146 was born to mother 21 here. So here's mother 21 here, and she's recovered, but the baby she birthed was 146. Here we are, 146. Boom. Okay. So number 146. Well, oh, sorry. What am I doing? Okay. I want to go back up to population. So here we go. Okay, 146. Okay. Oh, okay. 146. A baby named that was born. Okay. Yeah. So baby 133. It looks like baby 1. Okay. Unfortunately it's renumbered since it was born, I guess. Baby 133 is still here and is susceptible. So basically these numbers correspond to their position in the population. Now we could easily keep track of this more readily. For example, we could add a parameter for a baby that points to the mother and says, who is my mother?
So you just put baby in between quotation marks and trace line?
Sorry, here? This one? This one here?
Yeah, the plus baby.
Yeah, the plus baby. So what this is doing is, it's saying print out, that's what this trace ln says, print out on the console, the following. A baby named, that's this first part, and then substitute in there basically the name of the baby. That's what this thing is. And then say was born to mother, That's what this next little bit is. And then this next little bit is the name of the mother. There. So that's what I did. I'll put it up on the big screen if that's, can I get rid of this thing here? No. So this is mostly the code we had earlier, but mother equals this, that's the mother. Here's the baby. This is just the name for the baby. Before we just had this, oops, we just had this thing, but we want to give it a name, and that's baby. The mother is the current person transitioning, that's why we can say this. And then we ask main to apply the network, and then we printed out the name of the baby and the mother. Now, here we could remember which baby was born to which mother. And in fact, one of the models I provided to you does exactly that. It keeps track of family structures. All the children born to a mother. Each child knows who their mother was. That is important for certain models, right? Even a model of dental health where Streptococcus mutans may transmit from the mother to the baby post-birth. This is an area that Kurt knows a fair bit about. It can transmit to the baby. We might want to have a persistent connection between the baby and the mother. So we can have a parameter that would point to it, but I think what was suggested earlier was that we connect them, and we're going to do that right now. So how would I do that? How would I connect the baby to the mother? Well, what we would do is we'd say baby dot connect to mother. And that's what we do. Okay? More than that, I want to put the baby close to the mother. So it's physically located in close proximity to the mother. And so what I could do is baby dot set xy. This will set its xy position. I'll do this before apply network. And I could set its xy position to being the mother's get x plus a draw from a normal distribution, say. Any logic's implementation of the normal distribution has a bizarre pattern of taking the standard deviation first and the mean second, which I consider horrible. And so this is their normal distribution, sigma and then mean, but this is what it is. And we're going to set their x and y position to be near the mother. So near the mother's, their x position will be the mother's plus some perturbation with a standard deviation of 10, and their y position will be the mother's plus a standard deviation of 10. And then I'll connect them to the mother, and then I'll apply the network so they're connected to others as well. So now, having done that, and I'll put this up on the screen here. This is what I did here. Okay, so we have the mother and baby. We set the baby's location, x coordinate, to be just a perturbation, a small variation around the mother's x coordinate. Same thing with their y coordinate and the mother's y coordinate. And then we connect them, ladies and gentlemen, to the mother, and we apply the network to connect them to others who are in their vicinity. Okay, so having done this, we can run this model. If people would like that up on the screen, I'd be happy to put it up on the screen longer. And I will run this forward here. And I would just note that babies are now being born in clusters. Okay. So, yeah, here's a baby, for example, is born to that family. There's a baby born here close to its mother, a baby born close to its mother here. Baby's being born. And here we go. So here's the code to do that. So we figure out who the mother is. That's the one undergoing this transition in the model, undergoing this transition. We figure out who the baby is. That's the one we've added to the population. We set the baby's location to be the mother's location plus a small disturbance, and the mother's and the baby's y location be the mother's y location plus a disturbance. we connect the baby explicitly to the mother, and then we request that Maine applies the network to connect it to other nearby people. And that, ladies and gentlemen, completes our birth sequence, which is probably considerably less painful than what your colleague's going through today. I know, it looks bad, but it's nothing compared to that, right? What's that?
That's joyful though too.
Yes, that's true. That's true. Okay, so this is birth any logic style, okay, including co-location of mother and child and connecting them together. Okay, so ladies and gentlemen, I think we've pursued this model to its natural conclusion, and we will now proceed to investigate discrete event modeling and its combination with agent-based modeling. Any questions about this model? Open populations, illustrating birth, death, immigration within a single model, all in the midst of a spreading infection, and we could see the network structure evolving over time in response to the open population and births of babies and immigrants coming in. Okay, very good. So we're going to close that off, and I will post that post haste. So I'll just go and post this right now, and I think it's that same model. Here we go. There we go. Okay, so it's posted to the network. But now, ladies and gentlemen, we will close that model, and we will start with a clean slate.